Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, let me introduce myself. My name is Yiksi Hilmalia, NPM 2113-022071. And now, I am going to presentation about Pascal's Law. And the goal of this presentation is to make you understand about Pascal's Law and its application. Yep, Pascal's Law. Do you know what is Pascal's Law? Pascal's Law is a change in the pressure applied to an enclosed incompressible fluid is transmitted undiminished to every portion of the fluid and to the walls of its container. Blaise Pascal, 1652. Blaise Pascal is a French mathematician, physicist, and philosopher. And now I want to tell you about the kinds of fluids. Okay, as we can see, here are some examples of fluids. The fluid is included by air, water, gasoline, lubricating, oil, milk, and etc. Okay, now I want to tell you about the application of Pascal's Law. First is hydraulic lift. Hydraulic lift is widespread application in the industrial, construction, transportation, and etc. And the second is hydraulic jack. Hydraulic jack is often used to lift cars above the ground level for repair and maintenance. And the third is hydraulic brake. Hydraulic braking system present in the automobiles, like in your car or your bicycle or your motorcycle. Okay, and finally is hydraulic pumps. Hydraulic pumps are used widely in the automobile industry. And next is Pascal formula. This brings us to a very important formula. Yep, pressure is equal to force per unit area. And from here, we have a variant of Pascal law. There are, first, pressure is equal to force divided by area. And the second is, force is equal to pressure times area. And the last, area is equal to force divided by pressure. Okay, now let us take an example of hydraulic jack. This is an example of hydraulic system. Hydraulic system can be considered as a force multiplier. In most cases, oil is used as a hydraulic liquid. Here is a simple example of hydraulic jack which have two arms. The two arms of different cross-section. One arm have larger cross-section than the other. When pressure is applied to the small piston have to move larger distance than the larger piston. And the larger piston can raise a larger load. Now, when we apply force F1 to the left piston, then it will create pressure which is equal to F1 by 1. As we know, pressure is equal to force per unit area. A1 and A2 are cross-sections of two arms, and A2 is greater than A1. Now, cross-section of A1 is small, so we can generate greater amount of pressure easily by applying a moderate amount of force. Now, the pressure will be transmitted equally throughout the fluid and reach the larger piston. The upward force applied on the larger piston is at 2 times the force applied on the smaller piston. So we see forces get multiplied many times. Thus we can generate enough push to lift a heavy car by applying much smaller downward push in phase more piston. Okay, now here I have one example of the application of Pascal's law. We can see here, if the area of A1 is 0.01 meter cubic and the area of A2 is 0.1 meter cubic, external input force F1 is 100 Newton, then the external output force F2. How we can get the answer? Okay, let me see. If the area of A1 is 0.01 meter cubic, the area of A2 is 0.1 meter cubic, external input force F1 is 100 Newton, and what we want is external output force F2. Okay, now let's see the solution. Okay, the solution here is P1 is equal to P2. Okay, we use Pascal's formula of pressure is equal to force 1 divided by A1. Okay, P1 is equal to P2. So F1 divided by A1 is equal to F2 divided by A2. F1 is 100 Newton divided by 0.01 meter cubic is equal to F2 divided by 0.1 meter cubic. In A1 is meter cubic and A2 is meter cubic, so we can delete it. Next, 100 Newton is divided by 0.01 is equal to F2, that is what we want, divided by 0.1. Next, 100,000 Newton is equal to F2 divided by 0.1. So, F2 is 0.1 times 100,000 Newton. So, we can get the result that F2 is 10,000 Newton. Okay everyone, thanks for watching my video, and I hope now you all understand about the Pascal's law and how the application of the Pascal's law. Thank you very much for your attention. Okay everyone, that's all for me, and I hope you understand about the Pascal's law and its application. Thanks for your attention, and the last, wassalamualaikum warahmatullahi wabarakatuh.